This video is about classifying mixtures. By the end of the video, you should be able to determine if a mixture is homogeneous or heterogeneous and identify ways to separate a mixture. To remind you, matter is anything that we can mass or find a volume of. If it can be physically separated, we're talking about mixtures, whereas pure substances should be the same everywhere they go and shouldn't vary. A mixture will vary. If the composition is uniform and you can't see the parts, it's mixed very well, it's a homogeneous solution. Whereas if it's not mixed very well and I can see the parts, it would be heterogeneous. So let's go into this in more detail. A mixture is a combination of two or more elements, compounds or both, in no fixed ratio, and are not bonded together. Each substance in a mixture keeps its own properties. For example, salt, whether it's dry or wet, is tasting salty, and water is wet, and when you put them together, you get salt water, which still retains their properties. So they don't change in any way. And a homogeneous mixture means the substances are uniformly or evenly mixed. All the solutions are a homogeneous mixture. So if you say solution, it's a synonym for that you can't see its parts, homogeneous. So salt water, when you dissolve it, all the parts evenly mix, and you can't see it anymore because it's dissolved uniformly or homogeneously. There's tons of examples like this we talked about in class with milk, that it's homogenized so that you can't see the parts, but it actually comes out in multiple layers. Heterogeneous mixtures means that they are not uniformly, they're unevenly mixed. So oil and water, no matter how much you shake it, they won't mix and they'll separate into layers that you can see. In a diagram, a heterogeneous mixture means that you can see the parts, so maybe some of them are towards one side and some are towards another side, whereas homogeneously mixed means that they are mixed uniformly, pink, purple, pink, green, over and over again. So classify the following as an element, compound, or mixture. Sodium chloride, because there are two capitals, a sodium and a chlorine, is a solid compound. Whereas sodium aqueous means that the sodium chloride compound is now in water. So aqueous means that it's a mixture of salt and water. Specifically in this case would be a homogeneous mixture because we know that salts dissolve. So again, sodium solid means that it's the particles are connected, and then the aqueous means that then it's been mixed to water. So if it's a single symbol, remember with one capital letter, that's an element. For example, AU is gold. The capital A is the first part of the element symbol. If two or more combined symbols with two or more capital letters, that's a compound. So PBO, the P is capital and the O is capital. But if you have a mixture, it's going to say AQ. So which one is a mixture of substances? This might be an element, but this might be two different elements, so they're going to have two different symbols separated. When you separate the mixtures, a couple of things you can separate them based on. You can separate them based on their boiling or freezing point, their densities, like we saw with oil and water, whether their particle sizes, you might have done some kind of separation tube in earth science about that, solubility, if they dissolve or not, and magnetism. And this is just a few ways. There's tons of ways that we can separate them. So one of the most common ways is filtration. You might have done this if you ever drained like potatoes or pasta. You're filtering the solid from the liquid. So usually particularly takes a solid from a liquid, and it must be a heterogeneous mixture. So you have to be able to see the solid and the liquid so that the filtration system also sees it. We don't use a colander like you might at home. We use a funnel with filter paper, and the solid residue will stay on the filter paper, and the liquid layer will go through the filter paper into what's called a filtrate, or the beaker on the bottom. Evaporation is when we separate an aqueous solution and we take the water off so that you're just left with the salt, or any other substance like sugar or water would work. So you'd have an evaporating dish, you'd heat it, and all the solid would stay at the bottom or come out of the solution, and then all the water would leave. A fancier version of this is distillation, where you can separate a mixture, whether it's a solid and a liquid, or if they're two different liquids based on their boiling point. So what you'll do is you'll take a solution that has two things in it, you'll boil it on a hot plate. That's what number 1 is supposed to be, a hot plate. 2 is supposed to be the mixture. And what's called a round bottom flask, which is number 3. As it heats, some of them will evaporate. Whatever evaporates will go up this tube and through a condensation tube. Then at the point number 5, there's water coming in. It doesn't mix with the solution. As you can see, the water's in the outer tube. Your solution is going through this inner tube. And then the water that's going in from number 5 will come out in number 6. So there has to be like tubes going in through that just to cool it down. Because then if you have a gas that cools down, it would become a liquid about halfway through the tube and pour out on the other side. Notice there's a difference. These particles are darker than these particles because they're separating. We're taking out the, looks like yellow layer from that mixture. Chromatography separates things based on size and polarity. So you might start with different colored dyes and you put them on a line, mark them on a line on a piece of paper, and you hang the piece of paper in water. As the water travels up the paper, it will pull the colors with it, and you can see the colors start to separate. What used to be pink or orange is now orange and yellow. What used to be green is now blue and yellow. What used to be purple is now pink and blue. And I don't even know, the thing that's black is a mixture of multiple colors. So they start to travel up the paper. As the water rises, so does the color, and it separates out each color that it was made out of. So an example, a student wants to separate, I don't know why so is there, but separate a solution of sugar water. What method would they use? So if the sugar is dissolved in the water, I can't see the parts, I can't filter it out. So in that case, I'm going to use distillation or evaporation. So I would evaporate the water off or boil the water off to get the solid to remain. At this point, you should be determining if a mixture is homo or heterogeneous and identify ways to separate a mixture.